back to finish up section 2.2. We're going to sketch the graphs of a few more polynomial functions, and we have 2 more examples to finish up with. We are going to start off by finding the end behaviors and the zeros of the graph. We're going to sketch the graph, and we're going to clean up the graph a little bit by finding some additional points in each interval. So let's determine the end behaviors of the graph. What's the left side of the graph doing? And what is the right side of the graph doing? This is an even degree with a positive coefficient. So that tells me that the left side of the graph is going up and the right side of the graph is going up. So when we get ready to graph over here, I know that this left side is going to be going up and the right side will be going up as well. So that just kind of gives me an idea of what the ends of my graph will be looking like when we get there. So let's go over here and figure out what the zeros will be. In order to find the zeros, we set our equation equal to 0, and I will factor. Let's look for a common factor. Common factor here looks like we have an x cubed in common. If I take an x cubed out, I will have a 3x minus 4 left. And that's about all I can do there, and I will take each factor, set each factor equal to 0, and my zeros will be, if I set x cubed equal to 0, I will get 0. If I set 3x minus 4 equal to 0, I will get 4/3. So my 2 zeros will be at 0 and at 4/3. Now think back to the other examples we did, and let's think about whether the graph will be crossing or touching at these numbers. Go back to your factors. Remember, these are your factors. And look at the exponent of your factors. This is x cubed, which is an odd factor. This is 3x minus 4 to the first power, which is an odd factor. Since those are odd factors, both of these will be crossing the x-axis at those zeros. So let's go ahead and put these zeros on the graph over here. We're going to have a 0 over here at 0. And 4/3 is at 1 1/3, so we've got 1 1/3 about right there. And our graph will be crossing at those numbers. And that's about as far as we went in the last section. And then we were just kind of sketch the graph. Well, we're going to take it a little bit further now, and I'm going to draw a number line here. And what we're going to do is we are going to use this number line to represent our x-axis here, and we're going to put our zeros, 0 and 4/3 on here. This is sort of representing our x-axis, and we're going to find some additional points in each interval. In other words, on this area to the left of the 0, in this little area right here in between the 2 zeros, and over here in this area to the right of 4/3. And we're just going to do this over here on the number line so we can see it a little bit better. Now we know that over here on this left hand side we're going to have a value, a y value that's up here above the x-axis. We know that this is going to be a positive y value. We know that right down in here my y value should be negative because I'm going to be crossing over down here. And in this section, since I'm going to be crossing back up, I know over in this area I'm going to have a positive y value. So all you need to do is you just need to pick some x values to go back and plug in your equation and find you some extra points. And it really doesn't matter what number, just anything between negative infinity and 0. I mean, pick any number you want, like -1 would be okay. Go back and plug 3 times -1 to the 4th power minus 4 times -1 cubed. I'm just going back to the original equation. Plug -1 in there. That's going to be 3 plus 4, which would be 7. So that means the point -1, 7 will be on our graph. Well, let's put it on there. -1, 7, right there. Alright, let's find us a point in this interval right in here. That means in this little space. Alright, pick you a number between 0 and 4/3. I'll take a wild guess that most of you would probably pick the number 1 for x. Okay, there's nothing wrong with that. So go plug a 1 in there. 3 times 1 to the 4th power minus 4 times 1 to the 3rd. Calculate that. That's going to be 3 minus 4 will equal -1. Well, that means the point 1, -1 is on your graph. Alright, 1, -1 right there is on your graph. And let's go pick us one over here. Something to the right of 4/3. 2 would be a good one. Let's see. We picked 1 and we picked -1. Come over here. 2 would be a good number. You can pick anything you want. Anything you want. Just make it be something that you would want to graph. So this would be 48 minus 32 would equal 16. Now the way I drew my graph, 16 is going to be way off my graph. So this is going to be 2 and 16 would be like way, way, way up here. Okay, so we'll just kind of estimate. Okay, now sometimes that'll give you exactly enough points to graph. But I'm going to put you a little note here. Sometimes you may need even some more additional points. Because this graph does something kind of funny right in here. And if you happen to put this in your calculator, you would see that there's some funny little zigzag going on right in here. So I would like for you to calculate something in between 0 and 1 to see what's going on in here. And a good number between 0 and 1 would be right in here at 1/2. So right in here between 0 and 1, I would like for you to calculate x being 1/2 and see what that is. Okay, so I would like for you to plug in 1/2. 3 times 1/2 to the 4th power minus 4 times 1/2 to the 3rd power. And that would be 3. 1/2 to the 4th power times 1/2 to the 4th power times 3 will be, oops, I wrote that kind of big, 3/16 minus 1/2 to the 3rd, that's 1/8 times 4 is 1/2. And I know how y'all just love fractions. 3/16 minus 1/2 will give you -5/16. So that means the point 1/2 -5/16 is also on the graph. Okay, so positive 1/2 -5/16 would be around in there, giving us something like this for our graph. Cross here, crossing here. My little pen is not drawing very good. I'm sorry about that. Hopefully yours is going to look a little better than mine. Come up and hit that point. That point, this 0, that point we found, this point we found, and this 0. If you put that in your calculator, you would find something very similar to what we just calculated. And that is that example.